So this will be an introduction of Git on the command line for total beginners. So let's see what it's about. So what's the naive way to store and save your code and your versions? You basically have a folder and a bunch of files. Maybe you have multiple code files that belong to your project, and then you, if you have a certain state that you want to save or share with someone, you copy everything and put it inside of a folder. Maybe you even give it a date or name, so it's not like test 1, test 2, test 3. So basically you have your working directory, a current version, and then you just copy all of this into copies of your old state. But this becomes quite chaotic and confusing, and you have only limited metadata on your versions. With the time it will become a mess, and it's also very hard to then collaborate with some people on one project, because you will maybe send someone one version of the code and then you continue your work, and then someone edits a file and sends you back, and then now you have two files with different changes. So it's hard to do this. And now here comes version control systems in that will help you to manage your versions. You can annotate them with descriptions. The date and time and the changes will be tracked. You can manage different histories. For example, if you develop different features in parallel, then you can have different states in parallel and have a clear separation. You can move the histories between different repositories. We will talk about the idea of repositories, and also combine different histories from different users. And as explained, we will use Git for this, and we will do it on the command line. So you could also do it on the cluster on the command line if you want to. So locally, maybe you can use the command line or some GUI tools, but if you're using a terminal, then it's simply easier to use the command line. So for Git, you find some help in the man pages. So you can, for the general overview of the subcommands, you can use man git, but there's also the man git minus the subcommand. So for every subcommand, there is its own man page that will help you and describe what the subcommand is doing and all the arguments and so on. So let's start with the Git folder, and I will also again switch to the terminal here on the cluster, and we will also start with a new repository. So what's a repository? It's basically your little project folder. Let's say I'm starting here, then I will create a new empty repository with Git init, and it will complain a little bit, but it initialized an empty Git repository. So what does it mean? You've seen I just created the folder, and by creating a repository, a new .git folder was created inside of this folder. So here is all of the metadata and the history and so on of your project saved. So there's some configuration files and a database of all the files in there, and it's inside of your repository here. So the repository is basically a place where all the histories are stored. And now if you are using a git command, the git command will search for the next .git folder. So if you are in a subfolder, it basically looks inside of the parent folders until it finds a .git folder to figure out which repository to use. So you want to work with um, the Git repository. So the Git command needs to find the repository of your project. So let's start with the project. So this is an empty one. It's an empty repository. Let's start with git status, the first command in git status. It's very important because it shows you the current status of the repository and it says we are on branch master and no commits yet. So the master branch or main branch, how it's used nowadays, is basically the default name, and we have no commits. And let's start with some file. So this is my first file of my project, and to edit save a first state inside of my history of my project, I basically add this file, or let's say I'm using git status, and it says there are some untracked files because this is a new file and Git does not know about it and it does not track the changes of these files. But I can add it and prepare my first commit. So every time that you want to create a commit, so a new saved state of your project, you have to tell Git which changes you want to add into this new snapshot of your project. So I'm doing this, and now Git is happy. It has something for the next commit, and commit is basically just a name for the snapshot of your project. Just like in the previous example where you would do a snapshot of your project by copying everything, here you have to tell Git what kind of changes you want to put inside of this new snapshot. And now we can use git commit, and Git will open up an editor, and it will use, in this example, it uses Nano as a default editor. But if you set the editor environment variable to a different editor, then it will also use a different editor. And it will ask us to add a nice message, for example, initial commit. And it created our first commit. And as we see here, it used this default name that it figured out by default here to name our the committer and the author of the change. What we can also do is we can change the configuration to set a different name, because this is bound here to the cluster and my local account, and this is not nice and maybe confusing. So what we can do is we can use this git config command to change this. So let's say my name is Alex and my email is my university email address. Then these are now used in the upcoming commits as the name and the this email address. Now let's see what happened. So if we do git status again, it says we are on branch master, but the working tree is clean, so there were no changes, and we see my file is still there. But if we use git log, this shows basically the history, and we see there's one commit in our history. This is the snapshot that I just created. It says the author and the date and the description text that I added. And we also see that the snapshot got an ID, and this ID, every commit gets an ID, and this is you can identify and work with different snapshots by using this ID. Actually, you only need the first 8 or 10 characters, because they're often enough to identify the commit, but the complete ID is this one. Now let's continue working on the project. Let's add a parameter, and let's print something like this. And now ask git status again, and we will see git status says, oh, this file that I know of, because it's known, because it was already inside of my current snapshot, it was changed, and it will basically, maybe if I add a different file, we will see the difference. In git status, it shows us the modified files and the untracked files, so the new files. And now I can decide which of these changes I want to put inside of my next snapshot. This way I can, for example, I added 2 features at once. I changed maybe 2 files that belong to one feature and 3 files for a completely different feature. Then I can, for example, just add this these changes for my first commit. And here I'm adding the description inside of as an argument at the command line. So add printf. And now if I look at the log, I see I created a second commit, and the other change is still dangling here, and I can do another snapshot by telling Git what changes should go into the next snapshot. And now I can again commit it. And as we also see here, these commits already use this new configuration that I did for the name and the email address. So you always see who did these changes here. And as we also see, this is the current snapshot where that Git cares about. So if I change something or add a file, then it will always compare it to the currently checked out version of my Git repository. So we see here we have our working space with all the files that belong to my project, and the repository, and the snapshots are actually stored inside of this .git folder as different files, and there's some compression and some other intelligent things going on to manage all of these commits. But this is the working space that I'm working on, and if I add a snapshot to track what I did in my project, then everything is stored in this .git folder inside of the repository. Now we see that these commits have an order. So this was the root commit, this is the next one, and this is actually the parent of the second commit. And the second commit is the parent of the last commit. So we have a history, a path in our history. And as you see also here, this means head points to master. Head is always the one commit that Git uses right now to work with, to compare it with my working directory, and master is the branch. And we will see what this exactly means. So what we can do is we can use the git branch command with -v to look at our branches that are stored inside our repository. And there can be multiple branches. You can do different forking histories of your project, and this happens naturally if you're working with different people, and we will also see how to handle these situations. But first, we see that we have our default branch, and it is actually just a label for a commit, and here it shows which commit it points to. This is our latest commit. So every time if I'm currently, this is my current branch here, if I'm at a certain point and I'm adding a commit, then this branch gets updated to the new commit. What we can also do is jump around in history. For example, I want to go back to this commit, and now it's a little bit interesting because Git has to change files in my project. This did not happen before. I did the changes and then told Git about these changes. But now if I switch back in history, Git has to do things, and if it will notice, I can, for example, change this file. So Git now noticed that the file was changed because it always compares my working files with the commit it cares about. And what I now can do is I can switch to a different point in time. I can do this with another named branch, but I can also use the commit, and now Git actually complains because it's not a named commit, it's just a different one, just an unnamed one in the history. So I can use the detach. But now it complains about changes in my README, and it knows, okay, the README did not exist beforehand, and it was changed right now, so I don't know the changes that I did were not saved in the repository. So if it would now delete the README to get back in history, it would maybe destroy some changes. This is what Git is warning me about. And what was it, my project? So if I change it back, so now it sees working tree is clean, so there are no uncommitted changes. So Git now knows that we can switch back to this commit in time. And we see Git changed my working directory, so I can look at the different point in my history of my project. And we can also look again at Git branch, and here it says, okay, this is this named label for my history of my project, but head right now points to a different point in history. And here git log will also only show the point up to head, but if I look at the complete history of my branch here, then we see my head is right now, so my current thing that Git compares my working directory to is this one where I switch back to. So we can also open it and we see, okay, the changes that I did are not here. But what I can now also do is I can create a new branch. So this is like a fork in the history. So let me maybe, for clarity, so you see there's all of the things that I'm talking about you will also find in the repository, and also how what detached head means. So detached head means that my head points to some commit in between that does not have a name, and because it just points at one point in history. And what we're gonna do is we create a new branch that will be a fork in history. So this is by creating a new basic label, and then we can create a new commit, and this will be then a fork in history. So there will be two branches here. So let's see. I was looking at the first commit, that I'm creating a new branch. So now if I look at the complete history, we now see that there are 3 commits. I'm right now at the first one, and I created a new branch, and but my head is still pointing to like is detached, pointing at at commit. And now if you look, now the head is pointing to my branch. And now if I'm doing a change, let's go here and um, um, let's add something here and do a different message. But maybe I will also, to keep it in a working state, it's often a good idea to commit your project in a working state. So if you go back, then you can test something and it should work. And now I can see I'm at this branch and I've modified something, so I can select these changes for the next commit. And now we see there is no this new fork or a new commit, which basically is a fork because this is a different commit than this, the second commit that we ever added to the repository. And we can switch back and see this is my old history. And we can, with the git branch command, we can always track what branches we have. So how common is this thing? Is it maybe some esoteric thing? This is actually quite common because using these branches, when you're collaborating on the project with different people, um, then people, for example, will create an alternate history by doing some work on a different feature, as for example here, but you are working on some other thing, and then you have diverging um, paths in history of your project. Now let's assume that we want to combine these work. For example, the feature is ready for combining it in our stable version. Then we can do a merge. And a merge is basically combining two branches into a new commit. So this way, all of these changes can be combined into one new snapshot. So I'm right now at this master branch, and I have my great feature in this other branch. So I can now say, please merge the changes from this alternate history into my master branch. And now it complains. It tried to auto-merge the changes, and often it works. For example, my changes in the normal stable version of the history were only in one file, and all the other changes of the feature are in a different file. So the changes are in different files, and then Git can be smart and say, okay, I take these my current state with my changes, and I just add the changes from the other feature, and there is no conflict because they were in different files, so everyone is happy, and I will just create a new snapshot that contains all the changes. But in this case, we actually have changed the same file, and it's even worse, we changed the same lines. Therefore, Git does not know what is the correct change. And now it's in conflict merge conflict state, and we can look at git status, and it says yeah, you have unmerged paths, and here I was trying to merge, but it did not work, and here's a problem. Now you can abort the merge, then it will go back to your the state that you were before doing the git merge, or we can take a look and resolve manually this problem. And what we will find here is that this thing was actually the same. So we did the same change, no problem here, it matches. But in this version of the history, I named this argument argc and added this printf line, and in this version of the history, I added two arguments and this other printf line. So Git can't possibly know what is the right version. It's what makes sense for my project. It simply can't know. So the developer has to take a look and do this, choose the correct one, or manually combine them. For example, um, I can say I like this hello world better than this my project, so I will stick with hello world. But I actually like the adding of this argument, so let's uh, do it like this. And now what Git expects from me is that I do this, resolve this conflict, and leave the file in the state that it should be in the end. So there are all these informational lines from Git, and I can remove them. And this is the state as it should be when the two histories are combined. And now what Git expects from me is that I basically do a new commit. So I add what I changed, and I can do the git commit. And here it already says merge branch feature A. So this is already a little text here, because this is what I did. I merged the one branch into the other, and I fixed the conflicts. So let's save this. And what we can see here, a new commit was created, which actually has as parents these two previous commits. Now this is a very typical case when you collaborate with different people, and then you have a fork in your history, and then you have to merge these different histories back together to have a consistent project, basically. There is another, there are other ways to resolve these things, and you can in Git basically move the changes around as you like, and change the history after committing. So there are many things to, for example, clean up the history. Maybe you don't like that there are different commits here, even if they belong to the same feature, but you did them at different weekends, let's say, and you want to move all of them together, then you can squash these commits together, for example, and so you have a nicer history if you care about this. Maybe you don't care, and then it's also fine. Let's talk about one little other feature that at this point, which is tags. And tags are basically just a different type of label for your branches. If I look back at my history, there was this one commit, and maybe I want to give them a certain special meaning, then I can tag it and give it a name. For example, this was a very important commit in the history of the project. So I can give it a name. Let's call it version 001, and then I can give it a name. And as we see here in the history in git log, it has given it a name, and I can then even use this name instead of branch to, for example, switch around in the history. This is often helpful in the history, so people know exactly, okay, I want to have use the project at a certain specific version and not have maybe unstable changes in the most recent commit. Now, as we've seen here, this is all local. So you can use Git as a version control system locally to simply manage the version of your private project. You have a programming project or maybe any other different project. You can add binary files, images, and so on, but then Git can't handle them so well because Git has an understanding of lines. As we've seen here, it um, shown the differences or recognize the differences between the lines during a merge. So it basically focuses on text-based files. You can also add binary files, but then you can't really see, for example, with git diff, the differences between things. So I can also um, look at the div. Now I have to look up the arguments. So there are different combinations that you can do, but it always is something about which kind of versions you want to compare. So let's compare this version, and then it's shown, okay, these were the changes between the two versions. And this is not so easy if you have binary files. For example, if you put in some Microsoft Word files, then Git does not know about how to show you the changes in these files. So it works very well with text-based files, but it doesn't have to be code. It can be, for example, LaTeX or just a configuration file that is text-based, or a JSON file or something like this. And you can then use it to track the changes to these files. No, this was locally, but I've talked about collaboration. And for this, it's very useful to have a central repository to exchange files. And for this, let's there are as you know, different providers of centralized repository storage. You can do it on your own. For example, all you need to use it with Git is actually just one place that is accessible over the internet and allows SSH to all of the people that want to need to have access. That's basically just a folder that is stored somewhere that is accessible over SSH. That is everything that you need. But there are also these more advanced hosting services for repositories like GitHub or GitLab. And GitLab is, for example, often provided by universities to store and manage the projects of the researchers. So let's take a look at this. This is, for example, now GitLab project of my training account, and I can add here a new repository. I already added one, and here you can decide between a blank project or one with a template. A blank project is completely blank and there are no commits, and with a templated one there are already commits, and we can use this as an example. And just give it a name. And you can also keep it private or have it public so other people can also access it. And we can create the project. It seems to be a very fancy template. Hmm. Then let's take a look at a different repository while this is creating this very fancy project. So this is a public repository of mine under my account. And what you will find is here then clone with SSH or clone with HTTPS and so on. So you will also find this in GitHub. Now to clone it with SSH, you have to configure SSH for this server basically. And you would need to do this to use your private repositories. But you can, if it's a public repository, you can always clone it with HTTPS. And cloning means that we create a copy of the project locally of the repository. And for this, as you see, I'm back in my home folder, not in my project folder anymore. And I'm doing git clone and this URL that I got from the project web page. And it created a new folder called research code. And as we see here, it is a repository because it has a .git folder and it has some files that I created as an example repository. And I can do git log and see all the changes, because if you clone the repository, then the complete history of the project is also copied. And what this means is that you have a local copy, and even if you don't have internet anymore for whatever reason, for example, the central um, repository hoster is down, then you can still work with your local copy and look at the commits and create new commits, look at the history and so on. And you can already prepare some changes. For example, you are on a flight to a conference, still want to work on your project on your notebook, you can already prepare some commits. And once you landed and have internet, then you can push all the commits back to the repository. Okay. And what we see also here is that in Git branch, you will find some other branches now. Now we have our normal default branch here of the project, but we also have these special branches. They already say remotes origin main, remotes origin head. And what this means is here now we also have remotes, and remotes are just URLs to external places, to other repositories. In this case, it's already predefined by the clone operation. We told git clone where it comes from, where it should get the repository from, and git clone created this remote origin. This is the origin of the repository, and this is the URL. And now we could work with that, and if you authenticate to the server, then we could push our own changes to the remote that is defined here. And we can have different remotes. For example, we could have the same project in our university GitLab, but also on GitHub and maybe on a backup server, and have different remotes, and then decide where to put our commits to if we create a new commit. So let's see if this thing, it was created. And we can use the SSH version. And to use this, there are two things that you have to do. So you know about SSH and public key authentication, and this is used to authenticate yourself to the server here. And in the preferences, you will find this SSH keys point where you have to add your public key, and then you can use SSH to talk to the server. And now the other thing is that we have to tell our SSH client that for this server with the host of our GitLab instance and the user Git, it should use our key. And now if we clone the repository, we see it is like SSH. It says for the Git user, connect to this server and request this project, basically. Okay. I have to give it a different name because the folder already exists. Project new. And we see this is the state of our project here on GitLab. So we can also look at the history here. And this is basically the same as locally here. But now what I can do is I can do a change here, sample GitLab project. Okay, this is my awesome project. And I can create a new commit. And now if I look at the branches, okay, there were a lot of strange branches created. But we see that it says ahead 1, and this means I created a new commit that is not inside of my central repository. So basically, whenever I do an update or a clone, then Git knows what or remembers the state of the central repository. And now if I do a commit, I can do a git push, and I tell it where to push to. So let's say git remote v is here it's again called origin. This is the default name. I can push my commit to origin. And now if I reload here, we see that I commit to the project, and I can look at the history. Here I see the new commit, and I can have here multiple branches. For example, here these many template branches here as an example project, and then I can work with that. And there are a lot of features here in the GitLab project management features or continuous integration features and all these things that may be helpful with your project. But you can also just have a backup of your private project in this central place, so it does not only is in one place on your notebook, for example, but you can use it as a backup to put it there, so you know you have a backup of your code um, somewhere safe. So I've talked about this and all the nice features. So there are different workflows with Git. If you collaborate with many people, so or different models, where should you put, what should you put where in what branches and so on. And one often used model is this Git flow model, where you have one stable branch and have then maybe a develop branch and multiple branches for different features, so different people can work independently on their features, and if they are ready, then they can be basically merged into the stable version of your project. And then you can also have conventions inside of your project, for example, how to resolve conflicts or naming things like maybe you have a certain code in the description, because the first line in description is always shown in the GitLab or GitHub, and then the other lines are then just more details for people that want to know, okay, why, what was the change? Why was it changed? So later people can look up the history of the project and the reason for changes. Also, maybe a little convenience thing, what you can do is you can add in your Git bash config a little functionality that is loaded when bash is started, and then it checks if you enter a repository folder, it will show you that the current branch and if it was what state it is. So this can be quite useful. And at the end, again, some references to the official Git page, because it is very well documented. There is even publicly available book that you can read all the details about and all the how Git works and the history of the Git project itself, and some more external links with more training and information and so on.